Please join me in welcoming Andrew Nicholson.
Hello. I'm going to give a talk called Evolving Microservice APIs with Confidence. First, a small introduction. I'm Andrew Nicholson. I'm a software developer at ITHAKA, a nonprofit. I'm based out of downtown Ann Arbor, and we have several products. I think you heard from Michelle earlier, but the services I work on primarily support two of those products, ArtStore, an online database of over 2 million high-quality images, and JSTOR, an online academic database of scholarly literature, books, journals, and more. So the question I'm coming to you today is this question of, what does it take for me to be confident when I'm making a change in one of my services? And for me, there's sort of two big parts to that. One part is having automated tests that give me feedback after I make my change. Did my change have the effect that I wanted it to have? Did my change break any other services? And the other part for me is being able to have a mental model of the system, being able to understand the dependencies and the working parts well enough so that when I'm imagining what change I'm going to make or trying to figure out a course of action, I'm confident that the steps I'm going to take are going to get me where I want to go. And it's that second point that I'm going to be focusing on today, getting this mental model of the system. This picture sort of illustrates this idea of a mental model. If you were at DevOpsDays Detroit last year, you may recall this slide from Dr. Cook's keynote. This is from a report called the Stellar Report, which is a study of incident post-mortems in an effort to understand how engineers cope with complexity. And what's pictured here is several groups of people that are interacting with the system in various ways. You can see them in the middle here. And just so you understand, this isn't like a left-to-right workflow diagram. It's just several groups of people. There's people who are getting stuff ready to be part of the running system, people adding stuff to the running system, people doing architectural and structural framing, so maybe just describing the system, making diagrams. And then there's people who are doing monitoring activities, keeping track of what the system is doing. And what's sort of illustrated here is that these groups of people that are doing activities with the system, they're not actually working with the system itself. What they're working with are representations of the system, monitoring tools, console logs, dashboards. They're looking at source code, and they're looking at testing tools. They're not looking at the bits and bytes and looking at the wires. And even if they were, it would be too complicated to hold all in your head at one time. So when they're making decisions about what to do, they're working with these internal mental models of how the system works. And you can see them in these thought bubbles up there. And you can see that the different groups of people have different representations, so they're not always in sync. And they may or may not be, or they may be various degrees of difference from how the actual system works, which again is so complex that we wouldn't be able to comprehend it all at one time anyways. This quote from the report sort of encapsulates it. People interacting with the system are critically dependent on their mental models of that system, models that are sure to be incomplete, buggy, and quickly become stale. When a technical system surprises us, it is most often because our mental models of that system are flawed. So if having a mental model of the system is critically important and yet challenging because we have these representations, what can we do to make it easier for us to have better mental models of the system? And so I want to share with you today are some of the ways at ITHAKA that we interact that help with this sort of visualization and address gaps when gaps occur. So I want you to imagine that you're going to make a change in a service. Great. If you're going to be making a change in a service, you would probably be worried about or interested in what other things depend on that service. And if you're in a microservices environment, that may be many services. And so it might be helpful to have a diagram of all the different network calls and dependencies of your service. And so we might look at something like this. So this is a picture. I think I can get more. This is actually a visualization of the ITHAKA microservices architecture. It's produced by an application performance monitoring tool we use called AppDynamics. You just heard from them briefly. Let's see if I can break it down. I guess I'll throw out a couple numbers. We have over 300 independent services deployed, and each of those services may be an actual group of nodes or hosts. And those are these little green circles here. If you're sharp-eyed, you may spot a couple blips of yellow. I guess there's some warnings going on those couple services. I'm not going to spend a whole lot of time on that right now. These blue lines are sort of our network calls between services. Around the top or edge, you can see some of the resources that these services depend on. There's SQL databases up there. I see some caches, some message queues. And I actually didn't know this until I showed this slide to a colleague of mine. These four bigger circles are, if you drill down into those, you get visualizations just like this. So it goes further. So this is a helpful diagram in showing you that there's a lot of dependencies. But if you're actually going to make a change to one of these services, you might want to drill down. So this is the same diagram, except we're looking at one service and we're limiting to the immediate dependencies that it has. So this is a service called query service, and most of these services look like they use it, although it does call out to a couple other services. So if you were an engineer going to make a change in the query service and you were starting from scratch, you could use an image like this to get a sense of what might be affected and who might be affected. In this case, these various services are owned by several different teams, and so you could come up with like a maximal set of a blast radius or something like that. But we need to drill down a little more, because not all of the changes we make are directly in a service. Sometimes we have shared libraries that are used in a service but also shared amongst other services. And so we might want to see, if we were making a change in one of this service's libraries, we might want to see its library dependency graph. Well, I'll let you decide after you see it. You might have trouble reading that. So I'm going to zoom in a little more. This is the same graph but truncated, so it's just the immediate dependencies of this service. And there are still multiple levels, because some of these immediate dependencies are also used by intermediate dependencies. So even though this service uses this logging library, so do these other libraries. So imagine we were going to make a change in this library, IAC Service Wrapper. Some of these are third-party libraries, but some of them are libraries that we make in-house. And so you might need to make a change in one of these. And if you wanted to understand sort of the landscape of what is going to be dependent on that code, you could use a visualization like this to trace it to query service and look at the dependencies there. But it's a lot harder if you're looking at a service or a library like this to see what other services and other libraries are being used by it. No, are using it. It's easy to go from a service to seeing everything it's using on a source code level, but it's harder to go from a library and see who all is bringing it in. And so if you've got a library that's shared across teams, already for me there's some trepidation there. I'm going to have a hard time being confident that I understand all the usages of this module, and if those usages are in source code owned by other teams that I might not even know about, I'm going to be very careful with the changes I make. Be very strict about making backwards compatible changes, just adding new methods. And so the scope of what I can do is limited the scope of what I can do with confidence is limited. But it gets a little more complicated than that. I'm going to zoom out again. Sorry. This service happens to run on the JVM, which is, I think, in general, a great platform. But on the JVM, all the transitive dependencies are flattened. So at runtime, only one version of any library is available. And so this actually isn't the full dependency graph. That's the full dependency graph. All of these red boxes that are available now are conflicting versions of dependencies in this tree that were omitted because a different version of that library was chosen to be used at runtime. And so what this means is you can end up introducing conflicts and problems in a library just by changing your dependencies or bringing in new dependencies. Because it's hard to tell who's using you and what their dependency graph is. If this is like the whole diagram of our system, we might conceivably be able to trace through and understand how all of these different libraries are used. I'm not going to bet on that, but we might be able to do it. But if we've got 300 of these, you really can't guess with any kind of degree of confidence. So all of that makes it hard to, when you have a library that's shared across a lot of different teams, it makes it hard to make changes with confidence. So how do we cope with that? Visualizations like this help, but in general, actually, these problems discourage us from doing a lot of sharing at this level. We often prefer to share functionality, especially business logic functionality, via service calls over HTTP, et cetera, that we can more easily track. In a sense, this is actually not a problem specific to microservices. This is a general software dependency problem. But I would say before I started doing microservices, if I needed to share code, it was very natural to put it in a shared artifact and just include it in my other application. But now that that may be sending something across teams to many different people, one of the reasons we do microservices is to get this independent evolution, this independent decoupling. And if you're sharing a lot of code in this way, you can kind of undercut that by introducing hidden dependencies that are hard to see. So we weigh a lot more sort of what the cost of duplicating a piece of code might be versus this cost of hidden coupling. And if that's, it makes a difference in that kind of decision-making, whether we're sharing code across teams or just in the same team. If you're interested in more kind of discussion of the challenges of sharing libraries amongst microservices, there's this great talk by Ben Christensen at Facebook called "Don't Build a Distributed Monolith." And then there's this, the great book "Building Microservices" by Sam Newman. There's a little section in the integration chapter called "Dry and the Perils of Code Reuse in a Microservice World." So I want to talk now about how we sort of build a mapping of dependencies between services so that when we make a change at that level, we feel like we have an understanding of what's happening. If you imagine you have two services, one of them is My Consumer, and the other one is a service called Books API Service. This is a diagram of those two services, and you can see that My Consumer is a consumer of Books API Service. Got the little arrow. And we can tell, at least from one of the names, that we're going to be doing something with books. We chose a good name here. I guess we didn't do so well here. This is a side note. Naming's important. Don't name something My Consumer. If we had a written contract, I should hope it'd be better than this, but we might know that it gets book data, and we could detail that contract out to be, I'm just going to move over here. I'm left-handed. We could detail that contract out to be kind of explicit about the network call that's happening. It makes an HTTP request, it's a GET request to /books1, and it returns this response. And it's going to be a JSON response with several fields. So I think this describes a reasonable interaction, and it's pretty specific. You could rely on this for sort of a contract and an understanding of what the services are doing. And if you accept this as a contract, I want to pitch that it's a particular kind of contract, which is a consumer-driven contract. Consumer-driven contract. I don't have time to give that idea justice here, but I'll say the importance for this talk is that this description describes what my consumer depends on for this network call. It wants to make a GET request, it wants to send this data, and it's expecting this response. So it describes the dependency in the use case. It doesn't necessarily describe the full capabilities of the Book's API service. It may accept more parameters in that GET request, and it may return more data. So this contract is a description of this use case. It's not a description of the provider service itself. And so you could imagine if you had descriptions like this for all of your services, you could begin to answer some interesting questions, some questions that help you understand the dependencies well enough to see backwards compatibility. Is anyone using this field, author field? Can I remove it? If you have consumer-driven contracts against those providers, you can answer that question. That would be cool. We started to do this, actually, we started documenting our services in this way, and we got to about 2 of them until we stopped keeping it up to date. So it would be nice if there were a way to do this that could allow us to keep those contracts up to date automatically, because we have a lot of services, and it would be nice if we could do that in a way that the contracts produced are machine readable, so that we can be able to ask those broad questions: is this field used, et cetera. And it would be nice if we could, since these contracts are examples of interactions, those translate nicely, at least conceptually, to automated testing. It would be nice if we could actually have something that verifies that those contracts are being kept. And so this brings me to a tool that we've been starting to use recently called Pact. Pact is an open source tool. It's not one that we've made in-house. You can check it out on the web. And it's a tool for facilitating contract testing, especially consumer-driven contracts. This is that same sort of interaction formalized a little bit into Pact Form, which has sort of a request area. You can see there's the method get, the path /book/1. And then there's a section that describes what that response is going to be. The status code, the headers that are going to be returned, and then the body. Pact is actually a JSON specification for holding data like this, and a single Pact JSON file would include an array of interactions like this, and the file would sort of make up all of the interactions between service A and service B. And if you had interactions going the other way, you would have a separate Pact file describing that. So in every Pact, one service is the consumer, and one service is the provider. And that JSON actually here is rendered using a tool that they have called the Pact Broker, which is a tool that can help host your Pacts. So it's machine readable. How did this get made, and how can we use it to verify our contracts? The way that you produce these Pacts is pretty cool. There are DSLs that are in the Pact libraries that you use to write unit tests against your consumer code. So the client code of that my consumer service, maybe we can call it book getter service. No, that's not better. So you write unit tests that set up the interaction that basically describe this contract, and then the test executes your code against a mock server. And if your code produces the request that you said you were going to produce, the test passes and it generates that Pact file. And so you know if you've made these Pact files that your consumers are producing, are conforming to their end of the contract. And once you've got those Pact files, your providing services can spin up a server, pull down those Pact files, and basically generate each of the requests against the service and verify that they're providing the right response. And so it's very akin to mocking dependencies in unit tests, but you get this assurance that both ends of the dependency are actually conforming to the contract, which is very useful. So Pact for us is a useful tool in documenting and verifying our service-to-service interactions. Having these documents available and integrated as part of our continuous integration suites means that if we have a question about how two services are interacting and they're covered by Pacts, we have one place to go to answer those questions, which is a great tool when you're contemplating making a change and you're wondering if someone's going to be affected by that. They have libraries in several platforms, but they're always looking for more. So if you head over to their site and you don't see your platform of choice represented, feel free to contribute. CDC at scale. In a sense, the benefits, and I sort of touched on this earlier when I said we started doing this in a wiki and we weren't able to keep it up. But in a sense, the benefits here are from just applying the consumer-driven contracts pattern. But without a tool like this, it's hard to do that at any kind of scale. And yet again, this better mapping of dependencies helps us to make a better mental model so that when we make decisions, we feel confident. But sometimes we still have gaps. I've talked about some of the challenges that we have in understanding our dependencies, and it's not always perfect. So you can see there's a couple lines and then this gap in the middle. And when I think about gaps in the context of software development, mental gaps, often it goes with outages. Because often when something goes wrong, it's because someone's conception of how something should work or what would happen was not quite in line with reality. From that Stellar report I mentioned earlier, a common finding from analyzing post-mortems was this sense of, oh, I didn't realize it worked that way. Very reasonable statement. And so an outage then is an opportunity. This is something you might hear if you're walking around the ITHAKA offices. An outage is a terrible thing to waste. If it's an indication that we have some kind of gap in our mental model, then it's an opportunity for us to get together and try and close that gap. And so to do that, we use a tool called Blameless Postmortems. And postmortem, I think, is a pretty common term. You may have heard about Blameless Postmortems before, but if you haven't, there's this great blog post by John Allspaw at Etsy where he describes it. And essentially, it's an opportunity for the engineers involved in an incident to kind of get together and get to a shared understanding of the factors at play. They describe their actions they took, the effects they observed, the expectations they had, assumptions they made, and sort of build an understanding of a timeline of events as it occurred. And the focus of one of these blameless postmortems is learning, understanding, building a better understanding of the system. Root cause analysis and next actions are definitely involved in the process, but they're not the immediate focus. The immediate focus is for us to get on the same page again about how the system works. And the audience for these is not just the engineers involved in the incident. This isn't just about next actions. Everyone is invited to participate and listen because that kind of knowledge sharing and retrospective is valuable for everyone. At the end of each blameless postmortem, we produce a document that includes sort of the timeline of events. It includes those actions that people took and also their perceptions and what their expectations were during the event. And there's a couple of things that are valuable about this process that I want to highlight, which is that you get participating in a BPM or just listening, even if you're not involved. if you weren't involved in the incident. You get this subjective experience of the system and how it works. And hearing people describe not only how the system works, but their experience working with it gives you an appreciation that's valuable. When I hear a colleague talk about how this process takes 6 hours to run, and when it fails in the last 30 minutes, and when it fails, there's no output about what happened. And that makes this a very difficult and painful thing to debug and try to make changes in. When I hear that sort of frustration, that resonates with me, and I can more easily see analogous situations in my own work and in the system in general. And that sharing also builds empathy among the whole team, which is something we really value at ITHAKA. I can't do these guys justice here, but I recommend checking out that Etsy blog post. If you Google Blameless Postmortem, you'll find it. And there's also some links at the end. Gap. So with BPMs, it's one way we respond to outages and respond to these gaps in our mental model, and we try to remove them. Sometimes there's still gaps, but we get pretty close. So all this to say, to just illustrate some of the tools and ways that at ITHAKA we try and be able to have better mental models of the system and how we react when those mental models don't quite stand up. I guess we're concluding. Oh, wait, that's not all. This started with a talk about confidence, and understanding the system and feeling like you have a good representation is one part of that. But there's more things. Automated testing I mentioned is a huge part of that. I'm including a link to our company blog because there's some great posts there about automated testing that I recommend you go check out. There's also a post by me about Pact if you want to dig in a little bit more about that. And then some references if you want to learn more. This should be uploaded, so you don't need to write these all down now. That's it. Thanks.